You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. With the amount of new information flying at us on a daily basis, sometimes it's hard to back up and start from the top or rethink something that is considered somewhat trivial. Today, I want to look at two realizations I had this week about what you might call the basics or just foundational concepts that often get lost when we're doing more complex things based on those earlier tasks or learning components. First off, I want to start with what are embeddings? I found a good article by some folks at Cloudflare that gives a good definition. Sometimes it's really hard to find a very concise, comprehensible, I know those two things kind of contradict one another, but something that is well-defined and understandable on what some of these terms mean. So Cloudflare defines embeddings as representations of values or objects like text, images, and audio that are designed to be consumed by machine learning models and semantic search algorithms. They translate objects like these into a mathematical form according to the factors or traits each one may or may not have and the categories they belong to. Some of these terms are a little bit fancy, but at the core, an embedding is a numeric representation of a piece of data. The embedding itself can vary in size, but the piece of data that it's based on can also vary in size. It could be, for instance, a token, which usually calculates out to most of a word, or it could be an audio clip or an image or a short description or an entire video or a large document. Any of these things are possible. You can create embeddings from any number of these things. They're made up of features or characteristics for that piece of data. Let's take an example of this. For instance, book has a certain number of chapters, a specific author or set of authors, a tone that it sticks to, style of writing, if you will, a plot or a location for the setting, a certain number of characters and the different characters, a language that it might be initially published in, a genre, etc. Any of these sets of features and characteristics all come together to form a combined unique set that represents that specific book. If you think about how people are unique representations based on all the qualities and experiences that make up their being. Now, I don't want to sound crass and insensitive that we can create numeric representations of people. But if you think about the traits and experiences and things that make up a human being's perspective and what makes them, right? Then it creates this very unique representation of a human or a book or a piece of music. Let's go back to our books example, or music or animals or kitchen appliances. Creating a numeric representation allows us to understand and calculate how similar or different things are. Let's take an example of this. A house cat is probably more similar to a lion than it is a chicken because a house cat and a lion share more similar characteristics. For instance, their mannerisms, the things they like to eat, their long tail, their graceful mannerisms. Even though chickens and house cats might share certain things like they're similar in size or they're more commonly kept as pets and that sort of thing. But the similarity between house cat and lion is probably stronger because there are probably more features and characteristics that they share. So this allows us to compare and contrast different data formats. If you think about going back to our initial definition, we can create an embedding for an image or an audio clip or a piece of text. And by creating a numeric representation of that, then you can compare those numeric representations without fearing of their differences getting in the way, for instance. I can look at how a block of text is similar to a video clip, and just based on the numeric representation of that, I can compare those two things. So we talk about comparing apples to oranges and not being able to do that very well. Creating an embedding for each item allows us to compare apples and oranges then, based on the features that make up their being. The other piece I want to highlight this week is a realization I had working on a demo for an AI use case that I was working on. I've had this a kind of general application that I've been playing with and working on for a while now. And I was using Spring AI for a book recommendation system. My prompt that I was sending to the LLM was a question answering style. Hey, here's this search phrase that the user is looking for. Here's some data from a database as extra context. So I'm doing retrieval augmented generation, RAG architecture, and I'm passing all of that, the question and the data from the database, over to the LLM to provide an answer back. But my actual desired output was summarization style. What I really wanted it to do was summarize the results that I'm getting from the database. A colleague of mine pointed this out to me very kindly, that I was using two different styles. I was approaching the LLM in a question answer style. Hey, I have this question, give me an answer for this thing using this extra data as a base. But what I really wanted it to do was take the data and just summarize it for me. I used the default style prompt. A lot of use cases, especially last year and maybe even early this year, are still using quite often a chatbot style. I have this question. I need you to provide an answer. Here might be some additional context from a database or outside source that you can use to help formulate that answer. But again, that very kind of chatbot question answer style, where what I actually wanted the LLM to do was something totally different. I never really analyzed how my use case and my prompt didn't align. As soon as I aligned those two things, all of a sudden the use case is now working beautifully. So just a good reminder to take a look at your approach and the thing you're trying to accomplish, and make sure that those two things align and that your input is helping give you the best output. Reviewing earlier building blocks can help you form new connections or realizations you haven't considered before. That's exactly what happened to me this week. Numeric representations or embeddings make it easier to compare apples and oranges. So embeddings open new possibilities in search and other use cases. And then analyzing your strategy and approach on a project can also improve the output, whether that's stakeholder understanding or just communicating with an LLM. As always, thanks for listening and happy coding.